All right. Welcome back to Thursday with me. Over my illustrious mobile connection. I'm literally on the road right now. I'm actually sitting by the side of the road. It is December 15th. We're talking about data sufficiency, goal setting. It's a continuation of the topic from last week. So here's the copyright screen again. These problems are all from the free GMAT Prep copyright GMAC, unless otherwise indicated. Let's have a quick review of what this means. I think these names, I think about half these names were here last time, but goal setting and data sufficiency, like what exactly do we mean by that? So let's go to a blank screen and just make sure that we are on the same page there. So when we say this, and again, we do assume that everybody understands what the multiple choices are for data sufficiency. So if you don't know what those are, A, B, C, D, E, I can probably throw those onto the screen for you. Just let me know in the chat. Although we can't explain what sufficient and not sufficient are today. But at least if you need the choices, let me know. I'll put them on the screen. Okay, the sample problem that we used last week to illustrate exactly what we mean by goal setting was this. Let's just look at it again. Question is, what is 2x plus 2y? Statement 1, the sum of x and y is 5. Statement 2, the difference between x and y is 2. Okay, just look at that for 10 seconds, something like that. And then, just to make sure we're on the same page, go ahead and indicate what the answer to that question is using these choices. I'll give you like 15 or 20 seconds to do that. Okay, still about 5 or 6 people that don't have an answer indicated to this. There's no data sufficiency answers, right? If you don't have A through E picked here, just to make sure we're on the same page, let's pick something. If you don't know what the data sufficiency answer choices are, please tell me that like right now, so I can go fetch those and throw them on the board. If not, you should all have the A through E. Okay, so this is A. Just make sure we're on the same page here. The goal, when we're talking about goal setting here, the goal that we are actually setting is what the problem wants to know. In this case, that's this. This is the goal. What's not the goal? You can tell me in the chat box. There are a lot of things that are not the goal. You don't want to know what color the sky is or anything, but what might some people think they have to do that you don't want to do? There you go, right? You want to find 2x plus 2y as a single value for that entire expression. The goal is not to find x and y individually. This is the point. So, and this is actually, I mean, this is so centrally important, and this is actually the reason why they invented data sufficiency in the first place, right? Because if you have the correct goal, then you'll realize that statement 1 is sufficient, because if you have statement 1, you can just double it, right? So just double this, and that gives you the 2x plus 2y is 10. But statement 2 is not sufficient. So it might take you a second to prove that. Make sure you can prove that if necessary. Right? You want to prove it by just doing some very basic testing of cases. like, you can pick any x and y. You need x minus y to equal 2. So you can pick any x and y that do that. So like if x is 2 and y is 0, then 2x plus 2y is 4. If x is 102 and y is 100, well, we know it's a lot more than 4. So that's 2 different answers. Not sufficient. Okay. So it's A overall. Give me a smiley face if that makes sense. Smiley guy in the emotion icon area. Okay, now the point of this is that if you're trying to find x and y as individual values, it's all going to blow up in your face. Yes, it is. That's the point, right? Like, if you think you have to find x and y individually, it's going to go south in a hurry. You'll pick C, and you'll get it wrong. And let's just, we had this talk last time, but when do you get that wrong? Like, your reasoning goes wrong as soon as you think that. It's like before you even start doing the work, right? If you look at this and you think, I need to find x and I need to find y, you're gone. And before you even start doing the problem, it's like pre-order incorrect before incorrect is even in stores. It's like already incorrect. This is actually why they invented data sufficiency. Because in a multiple choice problem, if they gave you these 2 pieces of information, you would be able to solve the problem. I mean, you would actually be able to find x and y. You wouldn't have to. You would just waste a bunch of time doing that, but you'd be able to do it, is the point. Whereas, in data sufficiency, it's this thing where you might have to combine the statements, but you might not. And it turns out here that you don't have. So they basically invented the entire problem type of data sufficiency so that this approach would not work and this approach does. So goals, they are things. The takeaway from this problem is not hard, obviously, but it's very basic. But you can learn a lot. You can learn most of what you need to learn from super basic problems. So what you should take away from this forever and ever and ever is you need to be really precise about the goals. Like, don't change the goals of a data sufficiency problem. Don't do it. And I mean, one thing, I'm going to just kind of tell you this. One thing that might tempt you to do that is if you overdo this whole notion of rephrasing. Like, the materials do talk about rephrasing when it comes to data sufficiency. You should only rephrase things if you are absolutely sure that they are equivalent to the original. Like, if the question says, what is 2x? And you're like, I just need to find x. That's a rephrase. You can do that. It's like knowing what x is and knowing what 2x is, and they're basically the same. But any rephrase that changes the goal even a little bit is going to mess up the problem, so make sure you don't do it. Like, don't rephrase unless you are absolutely sure that it's exactly equivalent. So, if there's any doubt, don't do it. Okay, let's do a problem. Any questions before we dig into one here? Let's do it. Let's do a problem. Grab one for you. How about that one right there? That's where your multiple choice questions are found. Don't forget the goal of the problem. That That's the goal of the problem. Nothing else is the goal of the problem. Keep that in mind. Give it a shot. Give me a couple minutes to do it. Interesting. We got 4 answers so far, and they're all different. Okay, let me show you where we're at right now. Here's where we are. Here's the current crop of responses. Kind of all over the place. Nobody's picking E, but not really a consensus in what's left here. Let me give you a hint. Remember that today's topic is basically that, like, it's pretty much the same as this problem, except the problems are harder than this problem. But the basic idea is the same, which is you're going to have a goal. If you get too ambitious with finding stuff, you're going to think you have to combine the statements when you actually don't. Are there any choices that you guys suspect are just not going to be the right choice to these problems? Or like, what choice should you be a little bit? There we go. Does anybody know where I'm going with that? How this one works. Not saying that C will never be the right answer to these, but if you look at how this one works out, if you combine the statements and you get too much information, you can pretty much odds on bet that's not going to be right. Like here, if you put the 2 statements together, you wind up with X and you wind up with Y as numbers instead of this goal. That's the principle you want to keep in mind here. I mean, if combining the statements gives you more information than you actually want, don't pick C. Don't do that. Give me a smiley face if that makes sense. This is the single biggest giveaway that you're dealing with this kind of problem. Like if you put the statements together and you get exactly the goal that you want and like nothing more than that, then you pick C. But if you wind up with anything that's more specific, don't do it, guys. We're trying to get you. So like, let's talk about this problem. We want to know how many of the terms are more than 10. What should you not try to find? That's a question. Let me know in the chat box. Like, what should you definitely not end up with in this problem? Kind of like in this problem, you shouldn't end up with individual numbers for X and Y. Yeah, you should not end up with all the terms of the sequence. That's bad news bears if you do, right? By the way, what are the term numbers of this sequence? Like the terms in the sequence are numbered what through what. Yeah, it's terms 1 through 15. I mean, because look at what you have here. Like it says n is from 2 to 15, but that means you have to have all the terms that work for all of those n's, right? So the smallest n is 2 minus 1, right? Like if you write that statement out for the first few n's, let me blank down a little bit. Remember that the sequence subscript n just means the nth term of the sequence, right? So like if n is 2, that gives you a sub 2 equals a sub 1 plus constant. If n is 3, that gives you a sub 3 is a sub 2 plus constant. Etc. Same sort of pattern all the way until you get to n is 15. In which case the statement is a sub 15 is a sub 14 plus a constant. So you got to have all these terms. I mean, you have to have all the terms from A1 all the way through A15. Smiley face, if that makes sense. Also, about the GMAT in general, I only see smiley faces, if that makes sense. You got to have terms 1 through 15. Also, the GMAT in general will always start sequences with term number 1. They have never, ever not done this, and there's no reason to suspect that they ever will. Because remember, this is a test where there are no trick questions and there's no deception. If they started a sequence with term number 2, that would definitely be a weirdo trick question. They're not going to do that. So if you do get a sequence question, I promise you the GMAT will always start sequences with term number 1. If you've done things like Fourier series or things like that, Taylor series, you might, a long time ago when you took calculus, you might have started series with term number 0. They don't do that here. They're always going to start with term 1. So keep that in mind. Okay. So we have 15 terms. Let's label those. This is a sub 1. This is a sub 15 is the last term. What's the middle term, guys? It's halfway between 1 and 15. Number halfway between 1 and 15 is 8. That's the exact middle of the sequence. So that's the middle term. If you didn't, I mean, if you didn't calculate an average, you can also sorry about that. You got booted off the internet for a second there. The goal is to find out how many of these blanks are. Okay, let me move this stuff again. The goal is to figure out how many of these blanks are greater than 10. The goal is not to find the actual numbers in the blanks. Keep that difference in mind. The goal is how many of these blanks are greater than 10. The goal is not find all the numbers in the blanks. But this is the intuition that we're trying to build here. The intuition that I want you guys to have is if you actually do this, like if you actually end up with all the numbers in the blanks, your reality reaction should be like, oh crap. That should be your reaction. If you actually find all 15 numbers, whoops. I'm looking at you guys, everybody who picked C. There's a lot of you. Here's the answers again. If you picked this choice, which a lot of you did, you should be like whoopsie. I shouldn't have picked that. We smiley face if that makes sense. This whole goal setting thing. I mean, if it also helps, you can think about this from the point of view of the person writing the test. Like, they wrote this question, guys. They wrote this question for a reason. Like, if you actually found all the numbers, they would never have thought to ask you this. I mean, this question wouldn't have popped into their head. If you found all the numbers, they would just be like, hey, guys, what are all the numbers? Another way to think about it. So, the single most important intuition I want you to walk away with today is this. If you find all the numbers, you should be like, whoopsie, I'm wrong. And I'm being redundant here, but give me a smiley if that makes sense. See if we get more than 3 or 4 smileys this time. Okay, I see 5 or 6 of them smiling. Okay. Well, if it's statement 1, I mean, remember, if you get 2 different answers to this, that's not sufficient. I mean, one way that you can do this is to let that be 24. What's one way that you could make the sequence for statement 1? What's probably the first way that comes to mind to make a sequence starting with 24? Yeah, you probably, the first thing that comes to mind is probably something like 24, 25, 26. Just counting up by 1, right? Okay. I mean, right, like in this sequence, everybody's going to be greater than 10 because everything is more than 24. So like in here, in this sequence, all 15 terms are greater than 10. Now what the goal is, when you come up with specific cases, the goal is always to try to make 2 different things happen. As Ravi points out, you know that k can be negative. If you don't think of that right away, you can also look at statement 2, because remember, the statements have to work together. So when you see a 8th term less than 1st term, even if you didn't think of negative increments right away, you should realize, oh, hey, I can have a negative increment. So, sure, right? Okay. So you could make this gigantically negative. You could subtract 100 every time. So like minus 76, minus 176, etc. Here, only 1 term is greater than 10. That's 2 different answers. That's not sufficient. Smiley face if that makes sense. Any questions about that, please feel free to type them. Remember, smiley faces means the icons that are underneath your name. Just make sure we're all consistent here. Now I got statement 2. Statement 2 says that middle thing is a 10. Well, that's interesting. Let's divide this. Okay, now we're doing statement 2. There's a 10 right there. I mean, one way you can make this sequence go is, like we did the first time, you just add 1 every time. So 11, 12, etc. over here. And then this would be 9, 8, 7, 6, 5, 4, 3, the typo. Okay. So here you've got 8 terms that are more than 10. 7 terms that are more than 10. Just these ones. What else might we try? That's a positive increment. Let's try a negative increment. Let's say we should subtract 5 from every number. 5, 0, minus 5, etc. That means it's going in the backward direction, you're adding 5. Oh, look at that. Still exactly 7 terms that are more than 10. Is it possible for this to turn out differently? So you can see here, if you're counting down, this is going to happen every time. If you're counting up, this is going to happen every time. Can you have a series that's like 10, 10, 10, 10, 10, 10, 10, 10, 10? Is that a thing? Can you do that? Nope, because non-zero. You have to add or subtract something that is not 0 every time. So that means that every single time it's going to do one of these two things. If you need to try more cases to really be confident about this, then try extra cases if you have to. But every single time it's going to do one of these two things. Look at that, it's sufficient. It's always going to be exactly 7 terms greater than 10. Sufficient. This is B like boy. Notice you don't combine the statements at all. If you did combine the statements, again, what should happen is you should be like, uh-oh. Because if you combine the statements, like if you have 2 terms of a sequence like this, it's going to give you every single term. Because there's a constant difference. So if you put any 2 numbers in there, it's going to determine all of them, which should make you very uneasy. That's the point. See 1 or 2 people typing. Let's see what kind of questions you got here. And then let's see what you got. But notice again, goal setting, guys. Goal setting is the thing. I mean, as soon as you see this problem, you should count on. It's really just a matter. What you don't want to do with this is start trying to like memorize some incredibly specific rule for this. I mean, you probably could make some sort of rule where it's like if I have an odd number of terms and I'm given the median, then I know like exactly how many are more or less than the median. And that's not going to be useful to you because there's no way that you would ever get a chance to apply that again. So when you do this, because like some people have a tendency to do that, try to make rules on every single problem. If you have that tendency, what you should do is take what you get and just flip through a few hundred other problems and see if you can ever apply that again. And if you can't, then just trash it. It's not necessary. So like, it's not tricky. There's nothing tricky about this question, and there won't ever be anything tricky. And the question is stated in a way that's perfectly straightforward, and this is the goal. There's no tricks. If you have this goal in mind and you just test a couple of cases, you'll get the problem right. It's important that you not think of it as a tricky question, because it's not. Like, there's nothing deceiving about it, and there's nothing misleading about it at all. I mean, if you just test a couple of straightforward cases, you'll realize that that goal is always exactly the same. Not tricky unless you're tricking yourself. That's the beauty of it. The smiley face if this all makes sense. Move on to that problem. Let's do another one. Okay, so you got here. How about this one from GMAT Prep? These problems are all from GMAT Prep. Okay, how about this one? Remember, this is your goal. You should not expect to find anything more specific than that. Don't forget where your multiple choice answers are found. Okay. If you are still genuinely making actual progress, then keep going. No, you should stop. Remember, time management is not some complicated science on this test. Time management is really just, are you stuck or are you not stuck? A very brutally honest way to think about time management is just to think about, would you pay $500 to keep working on this problem? And I'd say, if you get it right, I'll give you back $505. If you get it wrong, your $500 is gone. I mean, these are not very great odds, but if you are sure enough that you're going to get this, you might as well bet, because, hey, you'll make $5. If you wouldn't put that $500 on the table, you're done. That's how time management works. That's all that it is, by the way. There's no minutes and seconds. There's no gauging the length of the problem. There's no, like, you don't have to do any of that. I mean, time management is just this. It's just identifying when you are honestly stuck. And quitting. So Ian, Nikki, Sri, if you wouldn't pay me $500 to keep working on this problem, you should pick an answer. $500. Okay, let's take a look. Remember, you got to answer every question on this test. So, I mean, we can't really wait any longer. But you don't do this. Don't sit here and look at the problem and stare at the screen. I mean, you got to pick an answer to it. Okay, this is a word problem. We've talked about word problems before. There are actually plenty of study hall sessions that are actually dedicated to word problems. Let me just give you the very basic rundown of what we've said about them. So, like, to make these more manageable, you should separate two things, which are organizing the problem. It's kind of like making an empty spreadsheet. I mean, remember when you first make Excel sheets in the real world, they're empty. Same sort of thing as that. It's like making an empty spreadsheet. And then everything else, and then filling in information from the problem statement. I have a few different kinds. Any numbers, of course, but also mathematical relationships. And don't forget to mark what the goal of the problem is. Do these separately. So in terms of physically organizing this thing, remember there's no math happening yet. It's like making an empty spreadsheet. When you make an empty Excel sheet, it's just like a sheet that has headings on it. And that's all it has. What would the headings be? No figures yet, no formulas, nothing like that, just headings, right? So you're going to have an April and a May. And then you've also got three quantities for that. You got revenue, and you've also got expenses. And last but not least, you got profit. So that's got to be in there somewhere too. Don't forget, the only thing that you have to know about business for this entire test is that revenue minus cost, also known as revenue minus expenses, is gross profit. They might just call it profit without the gross. This is literally the only thing you have to know about business to take this entire exam. So there's your empty spreadsheet. Those can be 3 columns. And then you can make rows for April and May. Whenever you get the same quantities in more than one time frame, it's good practice, right? Time frames as rows and things as columns. Okay. We did it. We physically organized the problem. Notice how manageable that is. Like, because we're not trying to, like, solve the problem at the same time. We're not trying to put all this math in there. This is not hard to do at all. It's only hard when you try to make the sheet and fill it in at the same time. You don't want to do that. You want to separate them. So now to get stuff out of the paragraph. 6% less. Let's just write that there. May was 6% less. So this is like down 6%. I mean, I'm just going to write that on there with words. And then the revenue was something. What's the point of telling you this stuff? For each month, the revenue is greater than the expenses. Is that a math relationship, really? Yeah, it's really just telling you profit's positive, right? So, I mean, you can write that. You can say this is like bigger, and this is smaller, and so this is positive. As long as you write that on there somewhere, it's going to be fine. And then, was the store's profit less for May than it was for April? So the goal of the problem is this column. You're just looking to compare the two boxes in that column. So the goal is the bottom box less than the top box. So remember, there's two possibilities for this. We've actually talked about making a specific device for yes/no type questions in other study halls. If you know how to do that, you should do it right now. If not, you can watch those other study halls in the archive. But there's basically two possibilities. One possibility is yes, the bottom is smaller. The other possibility is no, the bottom is equal or greater. So let's put those both in symbols. One possibility is that, other possibility is this. If you can get them both to happen, that's not sufficient. If only one of these can happen, that's sufficient. Smiley face if that makes sense, the goal here. So, not sufficient is what that should say. Okay. Don't forget that when you do these yes/no questions, ultimately it's kind of like I'm trying to make them both happen. So you're trying for not sufficient almost. Let's talk about it. How long should statement 1 have taken, you guys? Statement 1. Yeah, statement 1 doesn't tell us anything at all about this column. So what we're going to do is actually move everything up, because now we know what the problem statement is. So now we make another copy of this. Remember, it's good practice to always make 2 copies of any single chart that you make, or any diagram, any table, any sort of visual organizer. You might as well make 2 copies of it. Statement 1, I mean, okay, we know that there's a $2,400 difference. But if you gotta test cases, you can test cases. But like in statement 1, we know nothing at all about expenses. So I mean, if you want, you can just be like, okay, this is $2,500 and $100. And then you make these numbers up. Okay, let's say our expenses are 0 for both months. In that case, it's 2,500 in profit and 100 in profit. The bottom's greater than the top. once we get that to happen, the goal is to try to make the bottom bigger. I mean, that's pretty easy to do. We can just make the top profit really small. So we can keep these numbers the way they are. And then we can just be like $24.99, still zero. So now there's a $1 profit, still $100 profit down here. So that's not sufficient. You should do this due diligence, because I mean, just because you don't know one piece of information doesn't guarantee you that it's not sufficient. Because like sometimes one piece is all you need. Like if I tell you that, if I tell you I have an integer times an even integer, for example, you know that's even. You don't even care what the other integer is. So you don't necessarily have to know everything, but just make sure that you can work this out and prove that it's not sufficient. So I'm going to a smiley face if this workup makes sense for statement 1. Statement 1 is not sufficient. What about statement 2? Statement 2, this is 4% down. Let's write that on there. Okay. Does anybody see anything funky about this? If not, you can let's throw some expressions at this. Statement 2. What kind of expressions can you write for going down 6% and going down 4%? Yeah, if you take 6% off of something, that leaves you with 94% of it. So if this is like whatever revenue was, this is going to be 94% of whatever revenue was. If that's whatever expenses were, this is going to be 96% of whatever that was. And the profit, well, those are the profit expressions. Anybody got a story to tell me about those two? Can anybody tell me something about these? You could try plugging in numbers. Let's say everybody's got an intuition about it. Like, let's say that last year you made a certain amount of money and you paid a certain amount of taxes. And this part right here is like saying we only made, like, okay, we made 6% less than we did last year. But our taxes were 4% less. What if this was 0.94 instead of 0.96? Consider if you had revenue minus expenses or income minus taxes versus, what if it was like 0.96 R instead of 0.9? What if everything was 0.96? How's that going to turn out? Is this going to, are these two going to equal each other? Oh, what? Good guys. I mean, if you don't have the intuition for 96%, think about 50%. If you made half of what you made last year and you paid half the taxes, you would definitely not have the same net income. Heck no, you wouldn't. What would you have? About 100,000 in income minus 20,000 in taxes. Let's take 50% of each of those. That'd be 50,000 in income minus 10,000 in taxes. It's definitely not the same. I mean, like 80,000 net. You have a net of 80,000 here. So I mean, there's no way that's going to be the same starting out at 50. But it's just everything is half of everything in this case. Like if you have half the income and you also pay half the taxes, you're also going to have half the net. Like everything is half of everything in this case. Smiley face, that makes sense. But you're just scaling everything up or down by some percentage if we do this, right? Like so if you have half the profit minus half the expenses, half the revenue minus half the expenses, that's just going to be half the profit. It's going to be the same proportion of everybody. So, same sort of thing here. If you have these two things, this top thing is going to be some amount of profit. This is going to be exactly 96% of that profit. Smiley face if that makes sense. This could be a decent flashcard as long as you make other flashcards that do different things. I mean, if anybody was saying this would be the same, what you're probably mistakenly thinking about is ratios. I mean, the ratio of R to E is the same as the ratio of 0.96 R to 0.96 E. But those are ratios. I mean, ratios are not like amounts of profit. Like if you divided those, what you're doing is you're like finding your taxes as a percentage of your income. Like this divided by this is 20%. This divided by this is also 20%. Those are not net amounts of money cleared. So they're very different things. I mean, if you make a flashcard for this sort of thing, you have to also make flashcards for other things. Otherwise, it won't have value because you'll just like memorize it. But if you make a bunch of flashcards that do different things, that'll help you build intuition. So if you look at this, R minus E is greater than 0.96 R minus 0.96 E, which in turn is greater than that other thing. Like here's the thing greater than something. That's greater than that. Like this is less than this because it's just 96% of it. And then this is less than that because you made less money. It's like less revenue, same taxes. So this is even lower. That means that the top thing is bigger than the bottom thing. This is bigger than this is bigger than that. Therefore, this is bigger than that. That means that this is possible. This is not possible. That's sufficient. So it's B like boy. Let's get a couple people with questions. If you don't think of that comparison, you could just start tossing numbers in there. I mean, if you throw in, like, you should definitely try doing that on your own time. Like, when you do this later, like, try testing cases. Just so we have time to do one more problem, we're going to not do that right now. But if you try a bunch of different sets of numbers and they all give you the same results, that's not a fake pattern. Like, anything you pick will give bottom less than top. So after a while, you're just going to give up and be like, dude, that's sufficient. If you see this sequence here, like, I mean, thinking intuitively about things like taxes will help. You know, if you made 6% less and paid 6% less in taxes, you are going to clear 6% less. If you think of that, then you can realize this right away. But if not, then the last way that you can do it is you can also set it up algebraically. You can do that too. Let me just show you how to do that real quick. You got to set it up as a question. Like, is 0.94R minus 0.96E less than R minus E? You can just do algebra with this. And subtract 0.94R. Don't forget to keep the question word. You can also add E to both sides. That'll cancel here. And they'll give you positive 0.04 E over there. Anybody got a story to tell me about that? How about that? Don't forget, you will have to use everything they tell you in the problem. That's the last thing about this. Like, one thing that is super consistent about these problems is they will never leave significant information on the table. If they bother to specify something like this is always bigger than this, like, guys, you're going to have to use that. So if you don't use that, it means your answer is incorrect. So if you think about it, I mean, R is bigger than E. So this is 4% of a smaller thing, smaller percentage of a smaller quantity. And this is a bigger percentage of something that is already bigger. So that's definitely going to be true. So you can also do that algebraically and realize. That's another way of realizing that's always going to happen. So you got at least 3 ways you can do it. You can compare it intuitively for something like this. You can set it up algebraically. Or you can also just throw cases at it. You need to be able to do all 3 of this. Also, when you review the problem, don't forget that you should spend the most review time and the most effort on whatever methods you like least. So if you're like, this is easy for me, this is the method you should spend the least time reviewing. You should spend most of your time, if not all of your time, reviewing the other method, because that's how you get better at this. Like, practicing things that you're already good at, not going to help. Just keep that in mind. But you're only going to get better if you practice things that need practice. Keep that in mind. Okay, let's do one more. Let's do this one. There you go. Don't forget where your multiple answer choices are located. This is the last problem of the calendar year. Goal setting, this is the goal. What's not the goal, guys? What isn't the goal? Yep. If you identify the specific number for the area, you should be like, whoopsie. Don't forget. Go for it. Okay, if you're still going at this point, the question is, would you pay me $500 to keep working on the problem? $100. Gabby, Jody, Jose, Rosia, and Sri. Yeah, pick something. Okay, Jody and Jose, you gotta pick something if you're here. We gotta start discussing this thing, but I got a message for everybody who picked this choice right here. That message would be this. This is not a joke. If you pick C here, that's saying like I have all three corners of a triangle. Like if you pick choice C, you're like, this is 0, 0, this is 6, 8, and this is 13, 0. That means you have every single corner of the triangle. Like, whoops. I mean, because remember, they have to be writing these questions for a reason. This is another thing. I mean, if you think about this goal setting, you can think about it as like this is the purpose of these problems of data sufficiency, but you can also just realize that if somebody's gonna create this question, they got to be creating this question for a reason. Like no one's gonna randomly write a question that's like, is this more than 48? If you actually find it. So choice C pickers, if you have one specific triangle with 3 specific corners, the question would never say this. The question would be like, what's the area? Or like, where's the triangle? Let me smiley face if this makes sense. Goal setting. That's super important because if you think you're going to find a triangle, that means you have already lost this game before you even start playing. So like when you see this, you should absolutely 100% expect to find whether the area is greater than 48. You should expect not to find the actual area or the actual triangle. Like you have to realize that you are not going to find a triangle. Like this needs to be a 100% expectation. Because if you found a triangle, they wouldn't have asked it. On top of that, remember what we said about information and not leaving it on the table. Like they also told you this. If you don't use this, your answer is incorrect. Like, remember that there will never be superfluous information anywhere except the IR section. So the quant problems don't do that. So what that means, in other words, is if you don't use this statement, your answer is wrong. If you pick choice C, you should also keep that in mind too, because if you pick C, you don't ever use that. You're just like, dude, I have a triangle, and I'm happy. Nope. Okay, let's take a look. You should make 2 copies of the diagram, because you should always make 2 copies of any diagram for data sufficiency. There's second copy. Statement 1 and statement 2. Okay, let's take a look. Also, don't forget, if you're still not super clear on yes, no, data sufficiency questions, we actually have a couple of study hall workshops just on that. So make sure you know what your goal is. There's 2 possibilities here, which are yes, the area is greater than 48, and no, the area is not greater than 48, which means it's equal to or less than 48. And if you can make both of these happen, that's not sufficient. Smiley face if that makes sense. Okay, this is the goal, right? You got to know what you're doing from the beginning. You see smileys, a couple more. I only got 4. You give me smileys back. Just this whole fundamental here. Like, the whole point of this is if the area can be both more than 48 and not more than 48, it's not sufficient. If you're stuck with one of these, that's sufficient. Okay. Statement 1. Coordinates of this point are 6, 8. That means that this is 6. And this is 8. What the heck are we supposed to do with that pink statement, guys? Like this whole thing that OP is shorter and PQ is longer. What's the point of that? Yeah, right. Because if you theoretically had the same, you had a totally symmetrical triangle. Like if these guys were the same, then these guys down here would also be the same. So what's happening here is it's like you're just stretching out the right-hand side of that picture. It's like looking like that now. Like if you pull this out so that that's any longer than that, that means that this part is more than 6. Smiley face if that makes sense. It's like you're physically pulling this out. Well, you think in terms of areas, right? I mean, 1/2 times 8 times 6, that's an area of 24 for the left-hand triangle. It's not 14, it's 24. 1/2 times 8 times something that's more than 6 is something that's more than 24. That means your total is something that's more than 48. Look at that. This is exactly the goal of the problem. It's precisely what we're being asked to find. There's nothing tricky about it. And they wanted to be tricky. You could always find out that it was like more than 52 or something. They're not even going to do that. Like, I mean, they really want to reward you if you have the correct goal in mind. Like, they're not going to put additional triple wires in front of you like that. Like, if you know that you're trying to figure out just greater than 48 or not, you're going to get this problem right. It's totally going to happen. It's very straightforward. It's not tricky. It's not disingenuous. They're not trying to misdirect you. If you have the right goal, you're going to get it right. Smiley face, if that makes sense. Just keep in mind, if you got the wrong goal, you're going to get this thing wrong before you start the work. Like if you look at this problem and you think, I need to find where the triangle is located, you already lost the game. Nope, you're not going to find the triangle. Or this triangle can still be in all sorts of places, right? I mean, these 2 points are fixed, but you can put this point anywhere. That's not the point. The point is that you figure out it's more than 48. In statement 2, we know that this is 13. The problem in statement 2 is that we know nothing at all about the height. I mean, don't forget that data sufficiency diagrams are not to scale. They are like rubber band diagrams. They have to be, right? Like data sufficiency diagrams. Might as well write that in the screen. The reason for this is if you imagine a data sufficiency diagram being to scale, that would mean everything would always be sufficient. Because if there was a scale for the diagram, that would mean that everything had an exact measurement. So that's not how it's going to work. It's going to be stretchy diagrams. You can think about them as rubber band diagrams. You can stretch them, you can collapse them, you can distort them. You can't change straight lines into not straight lines, or vice versa. You can distort lengths, etc. So, like this height could be absolutely anything in the whole world. So, like, if this height is 0.0000001, you don't need to calculate that. You can see pretty easily that the area is going to be less than 48. And I mean, if the height is like 100,000, then the area is going to be a lot more than 48. So this is not sufficient. Give me a smiley if that makes sense. So overall, it's A like alligator. Sweet. Okay. That does it for Thursdays with me for calendar year 2016. It's a long time. I've been doing this thing for like 7 years now. 7 years. We're going to have the next one in January at some as yet undetermined point. It's probably going to be either January 5th or 12th. Don't know exactly for sure yet. It'll be posted on the website once we know. We'll give you at least a couple weeks notice. We should have those dates finalized basically by next week. Like before Christmas, you should know when the next installment is. So keep your eyes out for it. In the meantime, have a fantastic holiday season. If you're going to travel, travel safe. Spend some time with your family. Take some days off the GMAT, guys. Do not study the GMAT every single day of the holiday. I will come get you. Don't do it. All right. Thank you. A little bit over time. Gonna kill the microphone.